Hello guys, so this is the third chapter of our course Numerical Methods. It's called Linear Algebraic Equations. Okay, so in the previous chapter, the value x that satisfied a single equation which is fx equals to 0 is determined using many methods of the closed methods and the open methods. But in this chapter, we're going to deal with the case of determining many values of x, not really many, just 3, x1, x2, and x3, that simultaneously satisfy a set of equations. So we call this as linear equations. So this is like equation 1, equation 2, and so on and so on and so on. In the previous one, we're just solving for x that satisfied only a single equation. Okay? So in this chapter, you're going to learn 4 different techniques to solve for linear algebraic equations. The first one is what we call as Naive Gauss elimination. The second one, Gauss Jordan elimination. And then we have LU decomposition method. And the last one is Gauss-Seidel method. So for the first one, we call it Naive Gauss elimination. There are 2 main steps. So the first step is what we call as forward elimination, and the second step is back substitution. So this is a flow chart of showing all the steps involved in Naive Gauss elimination. As you can see that the linear equations just now are transformed into a matrix form. So this is just A11, A12, A13, C1, A21, A22, A23, C2, A31, A32, A33, C3. Now what's not written here is the X1, X2, and X3. So this is something like A11, X1 plus A12, X2 plus A13x3 equals to C1 any constant. Okay, so x are not shown here. So in the forward elimination, the main objective is to eliminate A21, A31, and A32. We would like to change these 3 elements into 0, 0, 0, and 0. So you will have then a new value of A22 with A22 prime and a new value of A23 to become A23 prime and a new value for the constant C2 to become C2 prime. And this goes the same as the third equation. We're going to have a new value of A33 to become A33 prime prime and C3 to become C3 prime without these 3 elements of A21, A31, and A32. So that's why we call it forward elimination, meaning we eliminate from top, first, second, and third. Okay, and then we have here, back substitution. So why the name back substitution? Because we are solving the x from the backward. So we are solving x3 first, and then x2, and then only x1. So that's why the name back substitution. Okay, moving forward. So here is one exercise. Given the systems of equations as follows: 10x1 plus 2x2 minus x3 equals 27, and so on. Use Gauss elimination to solve for the x. Okay, I'm going to post another video showing you on how to solve this problem using Gauss elimination for your reference. Okay, so for the next method, what we call as Gauss Jordan elimination, the steps are a bit extended because for this method, what you need to do is you need to transform all the elements or the equations into this identity matrix. Okay, 1, 1, 1 on the diagonal, and all other elements are 0. So in order for you to do that, you will get a new sets of value for the C1, C2, and C3. So these are all new values. Once you have transformed this into this, you can just easily solve for x3, which is this one. This one stands for x3, which is this value, and x2, which is this value, and x1, which is this value. As easy as that. But in order for you to come up with this identity matrix, I will show you in my next tutorial.